Good morning, everyone. I am Ahtesham Zaidi, a software engineer in L&T since past 3 years. So today we are going to discuss about Python and RabbitMQ. So this will be a very beginner-friendly talk. I am not going to deep dive into it. So let's start. So first, this will be our agenda. We will start with introduction to message queues. What are message queues and its drawbacks and why it's being introduced in the market. Now, after that, we will see the use cases and what is this RabbitMQ is all about. It's a little bit architecture, and then there would be a code walkthrough with a demo. And so forget me because there is one issue. This demo will be a recorded video. Okay, for that because we know how demo goes in live streams, right? It is never good. So okay, so let's start. So what is a message queue? So it is nothing but it act as a buffer between your producer and your consumer. So let's say if we understand in general terminology, let's say you are going to post your email. Okay, you have to post something. Let's say you are living in Bangalore and you have to post in Delhi. uh, uh, then what you will do, you will go to your post office, you will send your post, you will enter your address, your message will go in the content, and then you will send it. Now you are a producer. Your post office is nothing but a queue, a message broker. Okay. Now you don't need to worry how this message will reach to the recipient. You just deliver your post to the post office and you go back to your home. How it will deliver to Delhi, it is all responsibility of this post office. Here in this case, producer is you, message queue is the post office, and your consumer is the recipient. Now, once the consumer receive the message, it does the processing and do other stuff. Now, it happens asynchronously. That means you don't need to worry about the producer, don't need to worry how this consumer will consume it. It will just post it in the queue and the consumer will keep consuming it. Now, if we see a bit of its message broker, so it is nothing but it is a centralized hub between your publisher and consumer. You might have multiple consumer at the end. Let's say if the load is increasing at that time, you can increase your services. Okay. And also you can add a message broker in the end. So after a message broker, you can also add another message broker that will consume. Okay. This apps and all, this will become a publisher for you at that time. And it does a routing for you. What routing means is where you want to publish your message. Okay. So let's say you want to consume it. It may get consumed by different services. So you need to put some routing keys in your message while sending it. Then only the message broker will understand. Okay, I have to send it here. So before doing it, it first create a connection. Okay, you need to create a connection with your RabbitMQ server. The connection gets created in a channel. Okay, then after that, there is all this communication happens. Now this transformation, what it does, let's say you have written your code, publisher code. This is a very interesting thing. Let's say you have written your publisher code in a new language, let's say Go, but you consume the consumer service could be a different language, let's say in Python, Java, or any language. So I mean, this is also a very interesting thing of this message broker. So for an example, let's say you have a detail of an order and that goes into the message queue. It will get consumed by the payment service. So now why we need this message queue? So as we know, because in traditional architecture, they are quite tightly coupled, right? Everything is monolithic. Now, and there was direct communication between the components and that was leading to the bottlenecks because we have a lot of big architecture, lot of big monolithic architectures, right? In that case, whenever we are trying to use any service, it is calling synchronously all the services and it is creating a bottleneck over there. So to avoid all this, we introduce messaging queues. Now, if you look this architecture, this is not a button example. So in traditional approach, what is happening? Let's say we have three services.
Ahtesham, sorry to interrupt, but I'm able to see your agenda slides. Are you moving slides?
Oh,
Uh,
you're not able to see any?
so I am kind of stuck on agenda slides. Is it true for others also?
Yes, it was placed on agenda.
Uh,
Okay, let me reshare it.
Not sure.
Is it stuck here? Oh. Now is it visible? Or how?
Still on agenda. Okay, yeah, it's moving.
It's moving, right?
Yeah.
I think I don't need to do full screen. Okay. So this is okay. I will repeat once again. So this is how the producer and consumer works. Okay. So this message broker act as a buffer, and whenever you producer produce any message, it goes first into the queue. Then this consumer consumes it and do the processing, and it all happens asynchronously. So this is the message broker architecture. So let's say you have your publisher, and in between you have message broker. In message broker, there are different things like channels, connections, event, and data. So whenever you are creating a connection with your RabbitMQ server, first you have to create a channel, then only you will be able to make a connection. Okay. Now in consumer, there might be multiple services, or you might have another broker also. Okay. Now, what it will do, you because let's say if your load is increasing for a particular service, in that case, you can increase your these services pods. Okay, in that case, your load balancing will be done quite efficiently. Now, this routing, what it does, the routing means where you want to put your message from publisher. Okay, so let's say you want to consume in it app A, app B. Okay, you need to define in your message metadata where what service will get consumed. And transformation, this I have explained that let's say your publication is built in Java or Go, but your consumer could be in any other language, Python or any other language. Okay. So why we need message queue? Because there is a tight coupling in current traditional systems. We have monolithic architectures, we have tight coupling, and there is direct communication between components. So that is why our systems are not that scalable. To to basically mitigate this, we have introduced messaging queues. Now, if you see this traditional approach, so let's say we have three services. These three services are all independent. Okay, alert service, payment service, registration service. So whenever any alert is happening, this alert service is calling your email service. Whenever any payment is happening, it is calling email service. And whenever any registration is happening, it is again calling email service. Let's say all these things call, all these services call these email services at once. Now, what will happen in that case? Your email service will get blocked. Okay, it will fail in traditional approach. Now let's come to this messaging queue. Now, if you have introduced your messaging queue in between, what will happen? Because this queue is nothing what we learned in our data structures. Okay. It is a FIFO, that is first in, first out. So whatever message, whatever service request first, it will just queue it. Okay. And then email service has to deal with one message at a time. it it won't get bombarded with all these three services requests at a time. Okay, so this is a big advantage why we use message queue. Okay, so this we have already covered that advantages of messaging queue, that it decouples. You have your producer and consumer operate independently. Then you have asynchronous communication, which basically optimize your resource utilization. Then you have message persistence. That means whatever message you are sending, it will be reliable. That means, let's say your producer send a message to the queue and there is some issue with the producer service, it got failed, but it has sent the message, right? It will stay in the queue and the queue will send it to the consumer so that it will get processed. So no message or no request will get lost in this case. And this is load balancing that I've already told you, that if your surge peaks, right, you have lots of requests coming from the producer, then what will happen? You can increase your pods at the consumer ends. Okay. When you increase your pods, your load will get distributed, right? So it also acts as a load balancer. Now, these are few use cases of messaging queues. You can use because what we have earlier, we have monolithic architectures, right? Now we are moving to microservices. Microservices will have lots of different services communicating with each other, right? So in that case, we need messaging queue because we don't want the scenario what I explained in the traditional approach, right? And one more scenario is data streaming. So let's say you have all used YouTube or OTT platform. What happens whenever, let's say, you are trying to upload a YouTube video, and there are multiple processes after it. It imports and then put the bytes in the S3 bucket or whatever database being used. So in that case, these microservices have different, these, let's say there is a different microservice for upload, for encoding there is different service. So all these are connected with the queue so that the data will get transferred easily without any hiccups. And it is also used in event driven architectures. Now these are few different types of message brokers that we use. There is RabbitMQ, there is Apache Kafka. This is the most famous one. And then we have ActiveMQ, IBMMQ, and Amazon SQS. So if I am going fast, I mean, forgive me because there is one event that I have to attend after this call. So yeah. So these are the types of message brokers. Okay. Okay. So now what is RabbitMQ? RabbitMQ is nothing but an open source message broker. It is written in Erlang. Okay, it supports multiple protocols like AMQP, STOMP, and MQTT. Earlier, it was only supporting few protocols. Now they have introduced an AMQP also, and it supports different libraries like Java, Python. You can use any. You can use your client in any language. Okay, it supports most of the languages. So the basic thing is you need to have your server running, RabbitMQ server running. Okay, this is a bit of architecture of this RabbitMQ. So first we have your producer, and then you have exchanges. In other famous queues, there like Apache or Kafka, there is no concept of exchanges. In RabbitMQ, there is this concept. First, what happens? You need to visualize it as a channel. In channel, there is this connections happening. Okay, these exchanges, there are different exchanges: direct exchange, topic exchange, fan out, header, and default. So in direct exchange, what is happening? You need to define a routing key. Okay. If that routing key matches with your queue binding key, that message will get sent only to that particular queue. This is one type of exchange. Topic exchange, this is a different type of exchange. What happened in this? You need to define a wildcard pattern. Okay. That is star and then whatever you put after it. So if that particular matches with your queue binding key, the message will get sent only to that queue. So these exchanges are nothing but a way to send messages to a queue. Okay. Now there is one more thing, fan out. What fan out does? Fan out, you don't need to define any rule. If you define fan out, what will happen? If there is any empty queue, if there is no data to that queue, it will send all the data to those queues. Then there is two more exchanges as a header, and one more is default. So default, what we have used in our code. Now, what features of RabbitMQ? It is cross language, right? You can write your producer in different language and consumer in different language. It is more secure. It does message acknowledgement. That means if the message reaches to the consumer, it acknowledges the queue, yes, the message has reached. There is a good management control there is a GUI of this RabbitMQ that where you can see how many queues are running and all these things in visualized fashion. Then it is very cloud friendly. That means you can use it in any cloud services providers like AWS, GCP, or Azure, and it has different plugin for different languages. So this is all about RabbitMQ. Okay. So anyone has any question right till here?
So, Ahtesham, so you
Right.
mentioned that there are different such software sites, RabbitMQ, Kafka. So, is there any advantage that RabbitMQ has over others, or in what cases you would suggest RabbitMQ?
I mean, RabbitMQ we used. It is a very easy way to configure your queues, right? If you go and let's say you are trying to use Apache Kafka, like there is a big learning curve first of all, and then while you install and deploy it on your servers, I mean, it is a sort of big headache to do that. And, but RabbitMQ, it is very easy. There is one Docker image. You just need to, or there are multiple ways, right? The Docker image is the easiest one. You just take the Docker image of RabbitMQ server, you run it, your server is running up and running. Okay. Then you produce, I will show you the code. It is very easy to connect with RabbitMQ. I mean, basically the easiness of it makes it better, right? Otherwise, this Apache Kafka, I mean, it's been used in many big companies and everywhere Apache Kafka mostly being used. But for RabbitMQ, what it is very easy to get started.
Okay, thank you.
Any other questions? Because now we will be moving to the code walkthrough and a demo. Okay. Okay. If no questions, then we are moving forward. So, okay. So this is our producer code base. Okay. It is a very simple code I have written. Now we are using a Pika library to connect with our RabbitMQ server. First, what you have to do, you have to run your RabbitMQ server. Okay, you can either, I mean, if you go to the RabbitMQ website, it is very easy to set up your server. Okay, they have mentioned a good documentation over there. So first, your server, RabbitMQ server should be up and running. Now, this my server, what I have started, it was running on my local system, so I have put it localhost. If let's say your server is running on some different server, EC2 instances and anywhere, you need to put your IP address over here. Okay, in this line, we have created a connection. Now, I already told you that we need to create a channel. So here we have created a channel to make connections. Okay. Now, once we make a connection, we will declare a queue. What queue we want. Currently, we have declared a queue named welcome. Okay. Now, then we
Hey,
will try to publish it. Yeah.
hey, sorry for interruption. Can you go with the full screen?
A full screen. Okay, I will
A little
do
bit
it.
zoom will work.
Now, what is happening if I'm going to full screen? Are you able to see the slides moving?
Yes, slide says
Slides moving, right?
yes. Or you can little bit zoom out.
Uh, if you can increase the font size, I think that should.
One second. Because at my end, it is showing full screen. For you guys, it is also full screen or it is not?
No, it's inside the slide.
I will do like this, okay?
Sure.
You guys can see it now.
Yes.
Yes,
Okay.
it's visible.
Okay. So this is the Pika library we use to as a client to connect with RabbitMQ in Python. Okay. Now we have created a connection because our server was running on this localhost only. Then we have created a channel because inside a channel you can only create connections. Okay. Then we have declared a queue. named welcome. Now we will define the exchange. Here I have used a default exchange. For default exchange, you need to put only quotes. What routing key we want to send it to welcome. That's it. You need whenever you are defining a default exchange, you need to put a routing key as a name of the queue. Okay. Now in body, whatever you want to send, I have just written simple welcome to RabbitMQ. And then I am doing a print statements to check if that got sent or not. And then we are closing the connection to the server. This is the code for producer. Okay. Now we will move on to the consumer part. Do I need to zoom it out or it's fine?
It's fine.
Okay. Here also these three steps are the same. We have created a channel connections. Now we are declaring a queue named welcome. And then this is the callback function. What when once the message come, what will happen after it? So in that you can define your process. Now this consumer will start consuming to the queue welcome. Okay, auto act true. That means whenever a message comes, it will directly acknowledge it. Yes, it has arrived. And on message callback, you need to give the callback function. This callback function, basically you need to write your business logic over here. Then we will start consuming. Now, one thing you might have mentioned or noticed that we are declaring a queue again. Okay, so why we are doing it? Because let's say the producer has not declared a queue. Okay, then where these messages will go, it will fall, right? That is why we need to declare a queue in the producer or and consumer both, because this queue declare function is idempotent. Okay, that means if there is a queue named same, I mean, if the name of the queue are the same, then the queue will not get created again, because this queue declare function is idempotent. Okay, that is why we have to declare queue in all our producer and consumer code base. So this is a simple code. Do anyone have any questions here? Okay, I will move forward to the recorded demo. Are you able to see the media player or not? Tell me.
Not yet.
Okay.
Yes, we are able to see.
Good. Okay, so now we will start it. So it is a very small video. Okay, 20 seconds max. Okay, here we are starting our consumer that will keep consuming whatever message comes in the welcome queue. Okay. Now, whenever we produce any message, you will see it here. So this is a very simple example how this message queue works. Okay, in this producer, you might consider there is a service that is trying to send an email request, right? And this consumer is might email service that is trying to send the emails. Let's say you have multiple services coming that is trying to request email service, right? In that case, all will get queued, and then the email service has to deal with one as a request at a time. It will not get bombarded with all the messages, right? So this is a very basic, simple demo. We'll move back to the slides again. Yeah, I mean, this is it, I guess. So here, this is the code gist. If This is the code gist. If you want to scan it and use it, you can use it. If it's done, please tell me. I will move to the next slides.
Just one question from my side. So just like
Yes.
as you said, right? For the producer, if you produce one message and you can pass it to like multiple consumer, right? So do we have any configuration on the consumer side, like for consuming message from the more than one producer?
Correct. You can do the configurations also. There is configuration in the consumer part that multiple producer, let's say P1 and P2, can produce messages to only C1, that is consumers one, right? This also you can do. And you can also do that part where producer one, P1, can send messages to multiple consumers, let's say C1, C2, C3. This also you can do. Okay. So thank you. If you have any other questions, you can ask.